Now we are back with another information which is very common to use in our language, orthodontic language. We say a lot this. What is the center of rotation in orthodontics? The center of rotation is a fixed point around which a two-dimensional figure is rotated, as determined in its initial and final position. So if you compare before and after of one tooth or a group of teeth moving from one point to another, that point in which that figure seems to rotate, this is the center of rotation. Of course, the center of rotation is a bidimensional view for us, but this is something that has to be seen in 3 dimensions also. But for understanding what kind of movement we are planning for, just this, the bidimensional view is enough for us. We are speaking of it now. So when we see this before and after, we can say what was the center of rotation. It's very difficult for us to understand the center of rotation during the whole movement because it's not something simple to understand and something simple to view or to draw. But when we compare before and after and knowing where we want to go, knowing what our goal is in terms of movement, I want to do this inclination, or no, I want to do the translatory movement. I want just to go with my teeth like this, control a little bit for losing inclination at the end of the movement. So I can do that. I can at least plan for that because, as we talked before, not very simple, not mathematical, but it's important for us to know the goals and to understand that we can manipulate force, height of the force, manipulate the relationship between the center of resistance, and then a few slides and a few sessions I will talk about the possibility of adding to the system a counter moment. So all of those things are important for us to understand the kind of movement we are having. And center of rotation is part of it. It's part of it because we have to know what is the center of rotation that we want for that kind of movement we are imposing to the teeth, okay? In this situation I showed you before, we have the possibility of having a translatory movement, the translation of the teeth. I have the inclination of the teeth with uncontrolled tipping, or I may control it during the retraction if I want to retract anterior teeth, and we'll have different center of rotations in relation to that type of tooth or teeth movement that I'm having here. So we are talking about one point, just one point, when we see before and after, around which that figure seems to have rotated. So if I have just a simple movement, it's very easy because I just draw 2 lines before and after of the long axis of that tooth before doing the force, after a while, 1 month, 2 months, 6 months, and I just understand what kind of movement I have imposed to that teeth during that period of time. In this case here, we see that the dot point that we are seeing right above the center of resistance of this tooth is the center of rotation, because it is the point that did not move during this movement, did not move at all. It seems to be stationary. It kept its position while all other parts of the teeth, this tooth in this case, moved. So this is the point around which this movement occurred. Of course, as I told you before, it's not something that happened like instant center of rotation. Just if you compare before moving and after the result that you achieved after the movement finished. In this case, this is the center of rotation, but there are some situations in which we don't have this intersection in the body, inside the body of the teeth or tooth we are moving. How can we calculate, how can we see where the center of rotation of this movement is located? This is easy also. What do we do for that? We take 2 points before movement at one specific point of the root of this tooth or any part of this tooth, but two exact points of those before and after figures, and we take a far position. Now I'm using the tip of the crown, and before and after same point, I ligate those 2 points at the root and at the tip of the crown, and I bisect it. I take the middle of the position and I bisect it, and now I have the 9 degrees between this line and the perpendicular line, and where those 2 points cross, where there's the intersection between those 2 lines, it will be the center of rotation. Let's see how it goes here. It will be the center of rotation of this whole large movement. So in this situation, this is how we see what happened, what was the center of rotation of this before and after in this bidimensional figure. And if I just grab here the center of the resistance of this tooth, and I go like twisting this pendulum, I'll see that this is really the point around which the rotation occurred. Okay? There are people that say that it's easy to do that. We just have to draw the line of the long axis of the force, and when it bisects and when it crosses, it will be the center of rotation. But it's not accurate. Let's see and compare one to the other method of doing this analysis. For example, here I have it here, the intersection between these 2 points of the long axis, but when I grab the same way the center of resistance and I do the pendulum, the swing of the pendulum, I can see that it's not a point, because it has to go downwards in this movement, this center of rotation, and the whole body and this kind of pendulum. So this is different. I just don't do this kind of 2 lines unless there is a connection inside the body to see what was the center of rotation inside the body. Okay? It seems to be a little bit theoretical, but it's important for us when we do the calculation of the movement we are trying to do. Okay? What happens? You're saying, Clever, that we have to have this intersection to find the center of rotation, but I'm seeing here that movement, that translation that you said before, which is very, very parallel before and after position, because all the points of that teeth, that group of teeth, or just this tooth, moved, all those points moved the same direction, sense, and magnitude. How can we draw a line and have the intersection between them? We don't. That's what we call the center of resistance is located in the infinite. Okay? Because we don't have the crossing of those 2 lines. So in this case, we just consider that we have the center of rotation positioned at the infinite. Okay? This is how we call in orthodontics this translatory movement. So guys, this is for now important for us, and we are going to understand more and more about it when we address the retraction of anterior teeth. I promise you, it will all be clear when we address the retraction of anterior teeth, which is one of the most important parts, phases or stages of orthodontic treatment, and in which we need to have total control, absolute control of the movement. Of course we don't, but we try to. Okay? See you soon. Bye-bye.